This is the first 10.3 video where we're going to look at paired data. We're going to be able to determine when it's appropriate to use two sample T procedures and when it's appropriate to use paired T procedures. So paired data can result in two different ways when researchers record two values of the variable for each individual. For example, if we were doing an experiment where we wanted to know if music helps or hinders learning, then we might have this one student in our experimental group who takes a test while listening to music. We record their score. Then later, they take another test that's similar, can't be identical, but it's a similar test, and they don't listen to music. So they're getting both treatments, listening to music and not listening to music. And we compare their scores just between that student. So we're comparing that student with their score, listening and non-listening to music. And so we've essentially paired that student with themselves. The second way is if researcher forms pairs of similar individuals and records the value of one variable once for each individual. We're going to look at a good example of this at the end of this video, where we randomly selected sets of identical twins who are separated at birth. One went to a low-income family, one went to a high-income family, and we are going to compare the IQs from both of those two twins. So they've been paired together because they're identical twins and they're similar, and it controls for a lot of factors. And we're wanting to know the influence of low income and high income on their IQ and their development. If you think about our previous videos, we looked at how to do two sample T procedures. So those were the two sample tests and two sample intervals. And we looked at comparing the tree diameters from the north part of a forest versus the south part of a forest. Those are two separate populations. We took a sample from here, a sample from here, and compared the sample means. So that's an example of two sample T procedures. Paired is when it makes sense to treat one individual and pair them with themselves, or pair two similar individuals from an experiment. So before we can look at a T interval for paired data or a T test for paired data, we have to be able to determine when it's appropriate to do two sample procedures, two T procedures, or paired T procedures. So the way you can figure it out is two sample T procedures require data that come from independent random samples from two populations of interest or two groups from a randomized experiment. So the key is two separate populations where we take two independent random samples. Paired T procedures require paired data that come from a random sample from the population of interest or from a randomized experiment. So essentially, they're coming from one population if we're sampling, or if you've paired your individuals for the experiment, then you're going to do obviously paired T procedures. So let's look at two examples and determine which type of inference is appropriate for these settings. So in each of the following settings, decide whether you should use two sample T procedures to perform inference about a difference in means or paired T procedures to perform inference about a mean, and explain your choice. So before exiting the water, scuba divers remove their fins. A maker of scuba equipment advertises a new style of fins that is supposed to be faster to remove. A consumer advocacy group suspects that the time to remove the new fins may be no different than the time required to remove old fins on average. 20 experienced scuba divers are recruited to test the new fins. Each diver flips a coin to determine if they wear the new fin on the left or on the right foot, or vice versa. The time to remove each type of fin is recorded for every diver. So does this make sense for paired or two sample T procedures? And in this case, it makes sense to do paired T procedures because the data come from two measurements of the same variable, the time it takes to remove the fin for each diver. So each diver is essentially a block where you're comparing how long it took to remove the fin on their right foot versus the one on their left foot. So we're making that comparison for each diver. The next example, to study the health of aquatic life, scientists gathered a random sample of 60 white piranha fish from a tributary of the Amazon River during 1 year. The average length of these fish was compared to a random sample of 82 white piranha from the same tributary a decade ago. So in this case, we're looking at two sample T procedures because the data come from independent random samples of white piranha in 2 different years. So essentially, we're looking at 2 different populations, the population of the fish a decade ago and the population of fish currently. And we took samples from those 2 different populations to make comparisons. So this, no piranha are paired together. This is an example of when we would use 2 sample T procedures, either an interval or a test. This second example would be an example like we've done in the previous videos where we would do a 2 sample T interval or we do a 2 sample T test. But this first example, where we had paired T procedures, we could do a T test or a T interval for this example from the paired data, and it would be different than a 2 sample T interval. It's actually technically called a one, it's the same as a 1 sample T interval. And this information right here is our formula for a 1 sample T interval when we're using paired data. So it's our point estimate plus or minus critical value divided by or times the standard error. If we were running a test, then it would be a paired t-test, but it's the same as a 1 sample t-test. And this will be the formula for our test statistic. And so we're going to do an example of a t-interval and a t-test for a difference between paired data. And you'll see that it's the same exact process as a 1 sample t-test or a 1 sample t-interval, but we make the comparison before we start doing the inference. So I'll show you that here in a second.